Pre-calc 3.6, the second part of the homework. I'm going to start with 26. In questions 23 through 28, you are to find the inverse of, and the domain, the range of each function. So this one is y equals x squared plus 4. If you were to graph this, it is a parabola. It's 4 units up. So the domain on this is all real numbers. The range is y is greater than or equal to 4. So when you do the inverse of this, you have, start off with y equals x squared plus 4. You switch the x and the y, and resolve this for y. So subtract 4, and then square root both sides. So you end up with y is equal to plus or minus the square root of x minus 4. Now what you're going to have to do is switch your domain and the range. So your domain is going to be x is greater than or equal to 4, and your range is going to be all real numbers. For 27, this graph looks like it's 1 unit over. It's like a rocket. The domain on this is x is greater than or equal to 1, and the range is y is greater than or equal to 0. So when you do the inverse of this, you start off with y is equal to root x minus 1. You switch x and y. Square both sides. And then add 1. Whoops, x squared plus 1 equals y. Now you're going to have to switch your domain and your range because this is a parabola. So your domain is going to be x is greater than or equal to 0, and your range is going to be greater than or equal to 1. And the last one. This one is also a rocket. Your range, your domain is all real, x is greater than or equal to 0, and your range is y is greater than or equal to 0 for this one. When you switch this, y is equal to root 3x. You're going to switch x and y, square both sides, and then divide by 3. And now you have to switch your domain and your range. Your domain is going to be x is greater than or equal to 0, and your range, I should write d, and range is going to be y is greater than or equal to 0. You're just switching these two around. In the last 3 problems, you need to find the compositions of these. We're going to prove that this is the inverse of that. So what you have to do is f of g of x. You're going to prove that that's x. And g of f of x. You're going to prove that that's x. So the first one, if you put g into the f function, you're going to plug this in here. You're going to get x minus 1 plus 1. Well, these cancel and you end up with x. That's an easy one. And the other way, you're going to plug this in here. So you have x plus 1 minus 1. These cancel and you have x. That's your proof that they're inverses of each other. Next one. We're going to do f of g of x and g of f of x. So if you plug this in here, you get 2 times x over 2. Whoops. Let me start over. 2 times plus 3 minus 6. These cancel. 2 times x. These are going to cancel, but then this is going to give you 6. So you have 2x over 2 plus 6 minus 6. These cancel, this cancels, and you end up with x. And then when you plug this into here, 2x minus 6 over 2, this over here, and then plus 3. So 2, you can break 2 off, 2x over 2 minus 6 over 2 plus 3. These cancel, you end up with x. Minus 3 plus 3 is simply x. And the last one, we're going to do f of g of x and then g of f of x. So if you were to plug this in here, you have 1 over, this goes right here, 1 minus x over x plus 1. So this one you have to get a common denominator. You want to add these two up. So this becomes x over x. Now if you add across, these cancel. This 1 minus x plus x, the x's cancel. So you have 1 over x. And if you flip and multiply, you get x there. And then this one, if you plug this, you got to plug it in here and in here. So 1 minus 1 over x plus 1. That's moving this right there. And then put it over that same thing. So what you have to do here is get a common denominator. Right here, I would turn this into x plus 1 over x plus 1. Minus 1 over x plus 1 over 1 over x plus 1. What's going to happen is you're going to distribute this, actually subtract that. These ones cancel, so you have x in the numerator, x over x plus 1 over 1 over x plus 1. These x plus 1s cancel, and you have x over 1, which is x. Homework's done.